So here we're looking at figure 5.5, and what we're really trying to deal with is understanding how water moves through the soil and in the soil. And the way that we do that is by separating out, or by talking about energy states of water. So in figure 5.5, what it's really trying to get you to think about is the fact that water moves in specific ways in soil. And so we want to break those ways down and think about each one separately. The place we start right here at the zero potential energy level is you can think about just standing water. Okay, so water that's what we call free water standing in a pond. These sorts of things at a standard state, and so the description over to the left shows you that standard pressure, standard temperature, standard elevation, and these sorts of things. So that's kind of our reference state, and we can have water in a soil that moves from, in this case, we have a higher elevation to a lower elevation to that reference state, and that's caused by gravity. So you can see this gravitational potential that's right here. Okay, and so that's one way we can describe how water moves in soil is by a higher elevation to a lower elevation. Then we have other factors as well that cause water to be held in the soil in a tighter way than what we think about for the reference state. And so we have the example here of what we call osmotic potential. If there's salts in the soil, what we'll have is soil that doesn't move as easily out of the soil, or moves in a direction that's towards that salt water. So there's negative energies. Another one is this matrix potential, which has to do with capillarity and adhesion and cohesion of the soil matrix, which is just the soil itself. So it can exhibit tension or suction. So it's almost like it has the ability to draw water. That if you fall below, anywhere you go below this reference state, then you have the ability to pull water in a particular direction. So we've got this what looks kind of complicated equation 5.2 here, where we have the idea of the whole water potential, or the potential energy of water. So we can sum up all this stuff. So this is kind of like, how does water act in the soil is really what we want to get to. Well, it acts in a particular way because there's gravity working on it. We have a particular kind of texture, so the soil matrix is a particular way of drawing the soil from one place to another. We have more or less salts, so that one is osmotic potential. So more or less salts in the soil draw water in a different way, and then we have this one here, which is the hydrostatic potential, which really we don't. It concerns us in the soil, but not as practical as some of the other ones, and really observed as some of the other ones. And that hydrostatic potential, if you'll read further on page 138, you'll see that that's really talking about what happens to water when it is in a saturated zone. So the soil will be totally saturated. Now, how do we think of how water moves or doesn't? Some of those sorts of energy differences. So when you see this, first of all, you don't need to memorize this thing here. What you do need to realize is what we're just trying to say is water moves in a specific way in soil, and this equation helps us think about where it might move and what are the factors that determine if it moves sideways or down, or if water moves up in the soil, or if water is held tightly or if it's not held tightly. That's all this potential and energy discussion.